In this video, we're going to use a Raspberry Pi 4 connected to a gesture sensor to recognize different hand motions. We're also going to use an LED strip that we can control from the Raspberry Pi. Using code written in Python, we're going to learn how to display different animations based on different gestures that we recognize with the sensor. Alright, let's do this!
This video is sponsored by PCBWay. They're currently offering 10 pieces of 1 or 2 layer PCBs for $5 with a build time of 24 hours. They have any option you need for your PCBs, and the resulting quality of the boards is great. With friendly staff and great facilities, I highly recommend PCBWay for your PCB manufacturing needs.
In this video, I'm going to be using a Raspberry Pi 4, a MicroSD card that we've prepared in a different video, a USB-C power supply for the Raspberry Pi. For convenience purposes, I'm going to be using a hat that allows me to make wiring connections a little bit easier. I'll place both the hat and the Raspberry Pi inside the official Raspberry Pi enclosure, but I'll only use the bottom half. The input sensor that I'll use is the APDS9960 gesture sensor. As it communicates via I2C, I'll use 4 jumper wires for the connections. I'll also use a WS2812B RGB LED strip along with a JST header so that I can easily connect it to the Raspberry Pi hat. For powering the LED strip, I'll use a 5V 2.5 amp power supply. And to easily make those connections, I'll use a pair of screw terminal to barrel jack adapters. The last thing I'll need is a precision flathead and Phillips screwdriver. You're welcome to follow along or give it a try yourself. You can find all of these components in my little Amazon shop using the links in the description of the video. With everything mostly assembled, I'll give the sensor a try. Instead of connecting the Pi to a monitor and a keyboard, I'll establish a remote connection via SSH as I've shown in a different video. I'll need to enable the I2C interface in order to be able to talk to the APDS9960. Once I do that, I can run the command I2C detect with the option Y and the port to which you've connected the sensor. In my case, is port 1. If everything was wired correctly, you should see the number 39, which is the only I2C address of the sensor. To test it, I'll use an example from the GitHub repository. I'll leave a link in the description of the video. I'll need to use the Python package manager pip in order to install the libraries that'll allow me to use the sensor. As usual, I'll create a directory called work, and inside of it I'll make a project directory that I'll call gesture_LEDs. Then I can go back to the repository and look for an example that I can run. I'll use the test gesture example. I'll simply copy paste the code, save it, and on a different tab I'll establish a new SSH connection so that in one of them I can write scripts and on the other I can test them. You can do it in different ways, but this is the one that I'm choosing to use. If everything goes well, I should be able to wave my hand in different directions over the sensor and get the different gestures that it's reading. In case it receives a bad input or is unable to recognize the gesture, it'll simply say unknown. With the sensor working, I can give the LEDs a try. The connections are also pretty straightforward. With the LEDs connected, I'll go to the GitHub repository of one of the libraries that is available for controlling them. Once again, I'll use the Python package manager pip in order to install the libraries that I'll need. Similar to what I did with the sensor, I'll also use an example from the repository to make sure that everything is working. Once I verify that both the LEDs and the sensor are working, I'm able to write my own Python script to display different animations based on different gestures. To make things easier, I'll first write the code for the sensor, and then I'll worry about the different animations that I want to display with the LEDs. I'll need to include a couple of modules for the functionality of the sensor, and I'll also use the RPi module for doing operations with the different pins. I'll need to include the built-in module that allows me to use I2C communication. I'll also need to wait between measurements, so I'll need this function from the time module. Next, I'll define a few parameters. I'll also initialize the I2C communication on the correct bus. Then I'll create an instance of the sensor class. With these parameters defined, I can go ahead and write the main part of the code. I'll use a try-catch block in order to capture the most common errors. After initializing the sensor, I'll run an infinite loop that waits for half a second and then checks to see if the sensor has detected a gesture. If a gesture is detected, we'll run a comparison with the dictionary we defined. And for now, we'll just print out the recognized gesture to the terminal. With that done, and being sure that it works, which in my case I am, we can move to the LED part of the code. I'll go back and include the module that I'm going to need. And instead of writing out all the parameters that I need to define, I'll simply go back to the page and copy them from the example. I'll make sure to change it so that it matches the number of LEDs on my strip. Once again, for the sake of being efficient, I'll copy-paste the initialization of the strip object. And last but not least, I'll also copy a couple of the animations that I want to use based on the different gestures that are measured by the sensor. I'll choose the color wipe and the theater chase, but I encourage you to create your own. So now if I go back to the main part of the program, I can call these different functions based on the different gestures that are measured by the sensor. Let's say if the sensor detects an upward gesture, then the LEDs will display a red color wipe animation, a green one for a down gesture, a white theater chase for a right gesture, and a magenta one for a left gesture. Just so that I'm not completely lazy, I will define my own function to clear the LEDs once the animation is completed. Okay, so I'll be a little lazy and just wait 1 second and then call a color wipe to turn off all the LEDs. I'll fix the example code to match the modules that we're using. And the last thing I'll do is make sure that when we hit Ctrl+C to quit the program, the LEDs are turned off and the pins are reset. So we're ready to test things out. If I move my hand in this direction, I guess it's interpreted as a down motion. In the other direction is an upward motion. A little bit to the side is interpreted as a right motion, and in the opposite direction is interpreted as a left motion. So there you have it. Really quickly, we've built a device that allows us to recognize different hand gestures and display different animations based on those inputs. If you like my videos, I invite you to my Patreon page where you can chip in a buck or two. That really helps me put in more time into the videos and release them quicker. But whatever you do, don't forget to like, subscribe, or leave me a comment. You can also interact with me on social media. I'm on Instagram, Twitter, and Facebook, and you can even use the community tab of the channel. Thank you for watching my videos, and I will see you next time.